So today's learning goal is to understand the concept of factorials and the concept of permutations. Okay? Now, here are some of the definitions that we didn't go over in the last day. We kind of understood it, but now we're going to use it and define it. So here's the concept of the rule of sum. All right, so what I want you to do is I want you to wait until I've completed writing the definition, and then we'll do a problem here. So if one event occurs m ways, or another event can occur n ways, then what this tells us is that our number of ways these events could happen is m plus n ways. Now, the usual concept is there is the keyword or used for this concept, right? So here's an example. How many ways can you draw a 4 or a jack from a deck of cards? The answer is the following. Well, it's 4 for the 4s, because there's 4 cards that are 4, plus 4 again, which gives us 8 ways. Because there are also 4 jacks, and because they're not being, because I'm saying an or here, we don't look at them as events that occur simultaneously. It can either happen, or either this can happen or this can happen. So both of them have to be an additive sum. And that is the concept of the rule of sum. All right, so now here's the rule of a product, right? When we look at the rule of a product, you have something that is similar to this. So here is the rule of product, right? If one event occurs m ways, and example, I'm trying to give you the idea that something happens right after it, i.e. another event occurs n ways, then the number of ways that is described is m times n. Now, let's give an example. So, how many ways can you draw a queen and a 10 from a deck of cards? Okay. Now, you know that in a deck of cards, here is my queen. So we could set this up. Here is my queen. So it must be a queen, right? And then the next thing that comes up is a 10. So now you need to ask yourself, how many queens are in a deck of cards? Well, there are 4 suits, so we are going to take 10 of them. No, 4 of them. There are only 4. And because there are 10 more, for 10s, we're looking for 4 more, which gives us 16. So there are 16 ways for us to draw a queen, and in addition to that, right after it, pick up a 10. So the key idea for this type of problem is, the key word is the word and. If you see any counting problems that give you the idea that a sequence of events or ideas come after one after another, then you must use a times in order to describe the ways. these things can be organized. And that's why we have 4 times 4, because there's 4 queens and then 4 tens. And then we multiply them to get 16. Pause the video and copy this down. Then we'll move on to the lesson for the day, which is called the Factorial Notation. And here we go. So, what is factorial notation? Okay. The first thing that you have to understand is that there's 2 words here. It's a compound word. Factorial. What is a factorial? Let's describe a factorial. This is a factorial. Let's say I have 5 factorial. I write 5 times 4 times 3 times 2 times 1. Let's say with the concept of factorial notation, I give you the number 7 factorial. Write down what you think it is. If you think it's this, then you're right. So, a factorial is that. In English, we would say this is a factorial is what we have underlined here in red. Okay, a factorial is nothing more than the product of descending numbers. Numbers down to 1. One of the things that you should understand is that these are always integers. Greater than or equal to 0. And you'll see how this works. Okay? The concept of factorial notation is just a way to say that 5 times 4 times 3 times 2 times 1 can be written as just 5 with an exclamation mark. This is factorial notation. We use factorial notation to basically describe 5 times 4 times 3 times 2 times 1, and that will save us the amount of writing that we normally do. It just makes it more efficient to write the numbers 5 times 4 times 3 times 2 times 1. So here's an example. Ready? How many ways can I arrange 10 objects? So let's say I have a bag of 10 unique oranges. Okay? All right. So if I had a bag of 10 unique oranges, I could think of them as being lined up in 10 possible spots. In the first spot, I would have 10 choices for my oranges. Then I go pick the next one. Notice the word and. And means, and the very next thing you're going to do is right after it. So we have 9 possibilities left and 8 possibilities left. Down to 3 times 2 times 1. Isn't that just 10 factorial ways that we could have arranged all those things that were in the bag, whether it be oranges or cubes or different types of food? That is why it's important, because instead of having to write 10 times 9 times 8 times 3 times 2 times 1 all the way down to 1, you just have to write 10 factorial ways to arrange 10 objects. Get it? So now here are some cool notes about factorials. As a rule, 0 factorial is equal to 1. Think of it this way. Imagine you are locked in a room, okay? How many options do you have? You can't leave the room because you're locked in, so you have to stay. There's only one possible choice. Now, let me ask you. Here is something that I really want you to understand. Concept 2. If I have 2 factorial times 3 factorial, 2 factorial times 3 factorial is not equal to 6 factorial. In fact, it's actually 2 times 1 times by 3 times 2 times 1. 2 times 1 is 2 times, 6, which is 12. Okay? And now here is another thing. Let's say I have something like this. 8 factorial divided by 5 factorial. Well, 8 factorial divided by 5 factorial is 8 times 7 times 5 factorial. 8 times 7 times 6 times 5 times all the way down to 4 times 3 times 2 times 1. And what's 5 factorial equal to? It's just 5 times 4 times 3 times 2 times 1. And you know from your grade 8 days that 5 cancels 5, 4 cancels 4, 3 cancels 3, 2 cancels 2, and 1 cancels 1. So this is gone and this is gone. So we are left with the following. 8 times 7 times 6. And that gives me an answer of 336. Here is another key point I want you to remember. There on your calculator is usually something called n factorial. So let's say that I wanted to do, say, 4 factorial on my calculator. I have to use the following on my calculator. I have to punch the button 4. I have to hit the button on my calculator that looks like n factorial. And that will give me my answer of 24. Check it. Now, if you have issues with that on your calculator, make sure you show me a video of your calculator or a picture of your calculator, and I can identify that for you on your scientific calculator. Don't be afraid to stop these videos at any time, as you can save the amount of work that you're doing and actually either take a picture of it or write it down on your own terms. Don't rush. This lesson will be about 30 minutes. So now let's answer the following question. What is a permutation? Now, a permutation is no more than a number of ways n distinct objects can be arranged, right? So in math, or when you're writing the concept of a permutation, you're going to write it like this: P of NR. You'll see that on your calculator, or you'll see something that looks like this: NPR, really meaning N permuted R times, where we know that the value N here is equal to the number of objects, number of things we are arranging, and R represents the number to be chosen, the number of those things to be chosen. Things, let's call them arranged. So anytime you see the equation P, N, R, what we're doing is we're going to actually basically take the arrangements of all the things that we had, and we're going to divide out all the stuff that we don't need, which is N minus R of them in factorial form. And you'll see why this is important later, and you'll see me do some simplification to make our lives easier. So you need to remember this. When we have n objects and we are arranging r of them, that means we're going to have n factorial divided by n minus r factorial. And so now let's go on to our example. Okay, it's one of 2 or 3 that we're going to do. So imagine we're given the colors blue, yellow, red, orange, and green. Okay, now I need you to determine how many different 4 color combinations are possible if no color can be repeated. So the moment that you see that no color can be repeated, that requires a factorial. Now let's take a look at that. So at the beginning, it says the number of color combinations are what we're looking at. So how many colors do we originally have? Blue, yellow, white, red, orange, and green. So N is our colors that we have to choose from. And the number of colors is 6. Okay, now that we have our number of colors is 6, it says how many different 4 color combinations are we looking at? So in this case, we have R equaling 4 because we are looking for us to go through only 4 possible combinations. So just remember, in this case, we got to remember that order is important, because if we have blue, yellow, white, and red, it's not the same as red, yellow, white, and then blue. All the colors will be there, but they're in a different order. Good? So order is important. And that's when we use these things called permutations. All right? When you realize that, you can say you have n is 6 and r is 4. So now we can write P of 6, 4. We can punch that onto our calculator, or we can write it as 6 factorial divided by 4 minus 2 factorial. If you can't punch that in your calculator, you can at least punch in 6 factorial divided by 2 factorial, which simplifies to 360. Okay, so that means there are 360 ways for this to happen, right? The next problem we have here deals with a club of 9 people who wants to pick a president, vice president, and secretary. Okay, we need to determine how many different ways it's possible to choose those positions. Okay, so looking at the club of 9 people, that club of 9 people tells us that for our group or our arrangements, our solving, it's going to start with n is 9. Okay, so now that we know that n is 9, we need to know that we have 3 things to choose, because we have a president, a vice president, and a secretary. And guess what? Order in this case is definitely important, because our president and secretary and vice secretary are unique people within our organization. So in that case, we have to choose R. We have to go through R of them. So we are going to use the following. So because order is important, we have to permute them. So we're going to write P of 9, 3. Now, if you did this on your calculator, you would go 9, you'd hit this button here, NPR 3, and you would get your final answer. And we get 504 possible combinations. Now, I didn't do this in the previous question, but I want you to actually write your solutions. Therefore, there are 504 combinations. You'll notice that every time we do these problems, we always have to identify whether our order is important. If it is important, then we must use the permutation idea. Okay? So, an example. 10 horses run a race. Determine how many different ways you can have first, second, and a third place winner. All right, so here we go. Using our ideas, we look at the whole set. Okay, so there's 10 horses. So N is 10. And there is a first, a second, and a third place. So R is going to be 3. And in this case, because we have unique ideas of first, second, and third, order is important. And this is why we are permuting. So order is important again. And because it's important, we're just simply going to go and put in P of 10 and 3, use our calculator, remember. So you're going to have 10, you're going to punch in NPR 3, and you get your final answer of 720 ways. So therefore, there are 720 ways to finish the race. All right, let's do the next one. All right, so now we have a class of 20 people. We want to elect, and not a principal, man, I'm still thinking like a teacher, a president and a vice president. Determine how many different ways these positions can be filled. In this case, N is equal to 20. R is equal to how many spaces do we have to fill? There's 2, vice president and president, so that's 2. So our answer is P of 20, 2. Now we punch that in our calculator, we end up with 380. And now we say, therefore, there are 380 ways to elect. And we're good. So now I want you to pause the video and I want you to try this last problem here. We have a softball team of 10 players, and I need you to determine how many different batting orders can be there if everybody has a chance to bat. Okay? All right, let's see what you get. Now remember, I want you to do one more thing. Show the factorials like we did. Show the factorials. Using the equation for PNR that we used above to find this final answer. Then what I'd like you to do is I'd like you to do lesson 2's homework that I have posted online. Pause the video. solve it, and I'll show you the solution. All right. N is equal to 10. And since we're going to have everyone at bat, R is also equal to 10. And we know that P of 10, 10, based on our original equation for P and R, was N factorial divided by N minus R factorial, right? And P of 10, 10 is 10 factorial divided by 10 minus 10 factorial, which is 10 factorial over 0 factorial. Now, I need to remind you that 0 factorial is equal to 1. So our final answer is 10 factorial. Punch that in your calculator. So 10 factorial over 1 is just 10 factorial. And that gives us 3,628,800 ways for everyone in the baseball team or softball team to have a chance at bat. That's it. We're done. So what I want you to do is I want you to do questions 239, number 1 to 16.